Okay, hope this helps you do better on the test on Thursday. The first set of questions asked to identify and describe the rigid motions. Remember, rigid motions are reflections, rotations, and or translations. So if we look at this first picture here, here's your pre-image, since it doesn't have the little tick marks. And if I look at it, I've got it in the first quadrant and the third quadrant, and I can tell it's been flipped here. So that would be a rotation, a reflection. And it's over the x-axis. And I notice that I've gone 1, 2, 3 units right. So I've translated 3 units to the right and 1 unit down. If I look at my next picture, I can tell it's a rotation because it's a turn. It's rotated a quarter turn. So that's 90 degrees. And I can tell that I've slide, so that's a translation. 2 units to the left. Next, use the figure below to find the given measures. So if I want to find the measure of JE, I notice that here's JE is corresponding to AB or AC, so JE would have the same measurement of 4. Next, I want to find the measure of AB. AB is here. AB is corresponding to JD, so AB would be 3.45. Next, I want to find the measure of angle A. Angle A corresponds to angle J, so that would be 32.14 degrees. And then finally, I want to find the measure of angle D, and angle D corresponds to angle B, so angle D would be 87.99 degrees. Corresponding parts in congruent triangles are always congruent. What are the 5 congruence criterions? Remember your flip book? And I got a picture of somebody's flip book I used. So they are side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Remember, this can only be used in right triangles. No bad words with the criterion. Right on this, identify the congruence criterion and write a congruent statement. So if I look at these, I can see that this is an angle mark, this is a side mark, and I can mark my vertical angles. So the congruence criterion would be angle, side, angle. And then I would want to name the congruent triangles. Remember, you have to match up corresponding sides. So if I start with N, I can go N, W, E. And that's going to be congruent to O, W, T. If I want to do the next one, on the next one, I have angle marks and a side mark, and that's in both triangles. So the criterion would be angle, angle, side. If I want to name my congruence criterion, I need to match up my congruent parts. So I could say triangle O, D, G is congruent to triangle. Match up O with A, D with C, and G with T. Next, I want to read my marks. That's a side mark, that's a side mark, and I have the common side. So the criterion would be side, side, side. And now I want to name my congruent triangles. Remember, they have to match up the parts. So I could say triangle P, H, N. And that's going to match with triangle P, X, N. And then my last one for this, if I read my marks, I have side, my vertical angle, side. So the criterion would be side, angle, side. And if I want to match up my corresponding parts, I would say, let's erase those. Triangle U, triangle UST is congruent. If I go from U to S, I got to go from U to Y. U, Y, D. So there's identifying the criterion and name the congruent triangles. On these, I want to identify the theorem and find the value of x. On this one, I notice I have an exterior angle, so I would use the exterior angle. The exterior angle says that the sum of the exterior angles is equal to the two interior angles added up. I also can use the isosceles triangle theorem because I have these two sides are equal. So I know that the base angles are equal. So I know that x plus x has to equal 120. If I combine my like terms, 2x equals 120. When I use the division property of equality, x would equal 60. Next, I notice it's a parallelogram, so I know I will not be using any of the triangle theorems. If I want to find LP, I want to use the fact that opposite sides of a parallelogram are congruent. So LP would have to be the same as the opposite side, which would be 10. And if I want to find ML, ML is here, and the opposite side is NP. So ML was equal 12. On this one, again, I've got a triangle, so I know I'm not going to use any of the parallelogram theorems. I know they're interior angles, so that's the triangle sum theorem. So that tells me to add all the angles together, so I would say 4x plus 9 plus the second angle is 7x minus 13. The third angle is 2x plus 2. And the triangle sum theorem says they all add to give you 180. So now all I got to do is do my algebra. So I'm going to take and I'm going to add my like terms. 4x plus 7x plus 2x is 13x. If I add my constants, 9 and negative 13 is negative 4, plus 2 is negative 2. And that still equals 180. So if I use my addition property of equality and I add 2 to both sides, that would give me 13x equals 182. And when I use my division property of equality and divide both sides by 13, x is going to equal 14. And since the question only asks for x, that's all I have to do. But I could substitute in 14 into each angle and find all the angle measures. I notice I have a parallelogram here, so I know I'm not going to use any of my triangle theorems. If I want to find angle C is an opposite angle, so I use this theorem. Opposite angles of a parallelogram are congruent, so I know that that would give me 110 degrees. And then I also want to find angle D. Angle D is a consecutive angle, it's beside, so I'm going to use this theorem. Consecutive angles are supplementary, which means that they add to equal 180. So angle D plus 110 equals 180. If I use the subtraction property of equality, that would tell me that angle D would have to equal 70. I can check it because 70 plus 110 is 180. On this one, it asked me to find QN. Again, it's a parallelogram, so I know I'm not going to use any of my triangle theorems. That's part of the inside, so that's a diagonal. It says diagonals bisect each other. So that means that this line right here has been cut in half. So that means if LQ equals 9, then QN also equals 9. And then it wants me to find LN. So if both parts equal 9, then LN is going to equal 9 plus 9, which is 18. And finally, want us to find measure angle L. Again, I notice that angle L is an acute angle in a right triangle, so that's the theorem I would use. I know that it says they're complementary, which means the acute angles add to give you 90. So angle L plus 41 is going to equal 90. If I use the subtraction property of equality, that means I subtract 41 from both sides. I know angle L has to equal 49. And that's what the test is going to be like. Be sure to study those proofs that we've been doing for the class kickoffs. And remember to go back and look at scale factor and center of dilation.